guys, Aaron Productions here, and today I will be going over a little bit of how addressable systems work. And just as a disclaimer, this is not meant for a video of people in the field of fire alarm technicians. This is just meant for people that want to learn more. Maybe you are possibly thinking of getting a job at a fire alarm company. This would be a good video to look at, to have some prior knowledge before you go in to get your real training. This is not meant to train you on how to do anything. I'm not liable for whatever you do. So this is just to learn a little bit more about things. We're going to be learning about addressable systems. There are two types of systems mainly. We have our conventional systems, which usually don't have a screen. There are some that do, but these are very limited. They have zones on them. This one only has 2 zones, and basically it's looking for contact closure. And this is a little bit different. This is more comparable to sort of a DMX network, if you know what that is in lighting. Everything has its own address. There is an SLC, which is the communication loop for the devices, and basically every device, whether it be a pull station or smoke detector up there or anything like that, it all has its own separate address and its own separate module, so it switches between data and power, or I guess you could do it constantly at the same time with some new technology. It depends on how old the panel is. Everything has its own separate module in it, which obviously allows it to have its own address, just like any DMX network. So that's the big difference, is being able to address everything separately instead of having 2 long lines or more zones. I guess you could have like 10, 20, etc., depending on how many your panel allows. And that would be like you would have one going down the hallway and stuff like that. And with this panel only has one SLC, so obviously that would mean everything would be on one zone if it was conventional. But since everything is addressed separately, we can address different points to be for different things instead of having one zone be for a bunch of different devices. So for devices, they have things such as pull stations. As you can see right here, there's the blinking light. This wouldn't be available on regular pull stations because they're not polling or have any data going to them. So if I was to hook this pull station up to a regular system, it would not do anything. When it's pulled, it will go solid. And it will also tell the panel that this module, which is module 3, is in alarm. And I could program it for different things. I could even program it for what it's not, but obviously you do not want to do that. You can also have different devices which are conventional on these types of circuits. So what you have to do is get a module similar to what's inside the pull station, but this is external. This is automatically installed and you just hook up the SLC to the back. But this device right here, this carbon monoxide detector, is conventional. All it has is contact closure, so we can use a regular module. Now the regular modules do not output power from the terminals to power anything, but they do sell zone modules that allow you to use 2-wire smoke detectors or anything that requires 24 volts on the input side or the output side, depending on how you're looking at it. Also, with conventional systems, if you wanted to have something like a silent switch, you would have to set up a whole zone and waste a whole zone on it. With addressable systems, like, you can set this silent switch to be just one module, not waste anything but one point. There are also these things called control modules. They can come in forms of a relay, which you can program to do different things. This is a regular control module, which has 24 volts DC, which will turn on the output of it, and it also monitors it. So it's basically like a NAC, but it's programmable for more things other than just fire alarm. Like, this is just for the strobes. And there's also one over here for only the carbon monoxide. So you can program it differently than a NAC. So just think of it as a NAC with special features. Control modules allow things like voice evac panels to be easily controlled without using up the panel's NACs. So this obviously makes it easier and also more efficient to have more devices on the panel than wasting a NAC on a voice evac panel or some other source that needs the NACs in order to activate it. Relay modules allow you to control things, pretty much infinite amount of things that are electronic, without using the panel's built-in relays and wasting those all up on different things. You can have different modules, as many as your panel will allow, to control things like amplifiers, like I have here. This will cut off the amplifier if the fire alarm goes off so that you can hear it if in case there's loud music playing. I could also set it up so it plays a message through it as well. You can control HVAC, all kinds of stuff individually with the control modules. Disable anything if needed. You can disable individual zones. You can disable individual modules temporarily, and that is the nice thing about addressable systems, is complete control over all your initiating devices, including control modules as well. And of course, we have smoke detectors, heat detectors, smoke and heat detectors, and now they have the adapt, which is dual parameter, which means that they both have to be activated before the alarms will sound. And these have the module on them as well. So if I take this off the base here, the panel will give me a trouble, as you can see here, and it shows the device's number, which will be displayed on the outside. As you can see here, 1D002. It's not required to be on the outside of the device, but that just helps troubleshooting it. And it also says panel room, so we obviously know exactly where the location is, because obviously we have different labeling for every single device. There is also zones, which we'll get into in a second, but that's not important right now. So this is how most addressable firelight panels work currently. This is an MS9200 UDLS. The 9050 UD, and I'm sure the newer ones act a little bit differently. The 9050 UD doesn't support the adapt detector, so if you guys were thinking about that, then you would obviously not buy it if you had that panel, because it doesn't support it. I'm not sure if it requires light speed for that, or whatever it is. So obviously this is a regular panel. It requires 2 batteries, and also up here we have 4 NAC circuits. It doesn't matter how many you have. That's just how regular panels are. This is our resettable power here, and non-resettable, standard on every fire alarm panel for the most part. These are relays. These are programmable. It can be programmable or not programmable based off the panel that you have. This bus here, well, these 2 buses are for the annunciator. This right here is our SLC loop. I do have it set up as a Class B circuit, which means that there is no return. Let me just get the background out of here. Now, since this is, everything has its own address, if a device goes missing, it'll tell the panel because it stops communicating with it. This light would stop blinking on the pull station or whatever device it is, and obviously the panel would know that the device has lost its communication. So that eliminates the need for a resistor. You obviously need resistors on the NACs because those aren't addressable, unless you have something like a simplex panel where they're actually addressable. It is helpful to have a Class A circuit where it returns to the last device in the circuit, because if a wire was cut, it still has the communication coming from the other side. You will get a trouble, obviously, but at least it's safer that way. And you also have your 2 shield connections, because obviously with interference this could screw up everything, but for this system right here it's not a big deal at all. Now, one thing that all addressable systems have in common, well, I guess there might be some oddballs that do not have this, but you do have to program these. It's not like a conventional system where you just plug in the devices and you plug in the strobes and stuff like that. If we go into our programming here, we also have some other things like read status. I do have a video, which I'll put up right there, on how to program this panel. Obviously, still not meant to be like an instructional video for professionals, just maybe a little bit helpful to somebody who's playing around with these for fun or something. So if we go into programming mode, we have the option of auto program. Now what this will do is it'll scan for every single device on the system, and then it'll automatically put it in there. This won't put any names or anything on it. You'll have to do that manually. And thankfully this panel does have a PS2 input for a keyboard, so that makes it simple to type it in instead of typing it in on this like sort of old school cell phone type thing where you have to go like hit it a few times. The only thing is, if it doesn't detect the device, which I've had happen before, then it won't be programmed into the system, and basically that means that the device will never be active. It won't be looking for it. So make sure that every single device that you have on the circuit is actually in there, and not one device is missing or something, because once again it will never work, and if you don't know that it's not working, then it will never work, period. You can program separate points. Detector or module, you have to set that. You can add, this is mainly for adding one device, but you can add a device, delete a device, or edit a device. We can just go into here, edit module address, and we'll do the pull station 003, and here we can see all the information, type, There's different types of stuff here. Again, all devices have to be set to their respective device type. So this is an adapt heat detector and smoke detector, which is dual parameter. If I set this to be a heat and smoke detector, which it's not, it's an adapt, or if I set it to be a smoke detector, heat detector, pull station, anything else, it won't work properly. Thankfully for this device, it will give an invalid reply, but if you don't know why that's happening, make sure that it's set to the exact device type that it is. Also, in auto-programming with some of these modules here, especially the control modules, if it's a relay module, it's going to come up as a control module, which is something different in a way. So you would have to go into programming, or else it's going to give you trouble, and change it to 1FC. I believe that's what it's called in programming. All you do is go to the edit, and then you change the device type like I showed a few minutes ago, or else it won't work properly and won't work at all. It'll give you trouble. So that's unfortunate that it detects it wrong, but I guess that's just how it works. Here again, this is in the programming video. And you, of course, to delete it, you just hit 2 and then you hit 003 or whatever device number it is. If it was 10.0.10, it was 100.100 and stuff like that. And of course, adding, same thing, you just add the device. You would have to go escape and then edit to put stuff in, because all it does is say module added or whatever. Now there's also zoning. Now this does not mean like regular zones where you have contact closures. Now a zone is a bunch of addressable devices put together. So you could have, like in a high-rise building, zone 1 first floor, zone 2 second floor, zone 3 third floor, and so on and so forth, so that maybe zone 1 activates a certain module, and then that would cause the voice evac panel or whatever to play a message just telling the first floor to evacuate, and maybe the second floor, while telling all the other floors to stay calm and wait for further instructions. On this panel, everything is defaulted to zone 0, which is fire, but I do use the other zone. I use zone 1 for carbon monoxide, because you can't have it on the same zone or else the module wouldn't activate the stuff. So basically, carbon monoxide detector is on zone 1, and carbon monoxide modules that activate the devices like strobes and the horn that I have down here for carbon monoxide are on zone 1, and that allows those devices to communicate together. Loop setup. Now there's these things called protocols. For Firelight, there's light speed and clip, which clip is very slow. Clip goes through every device separately, so if you had 100 devices, it would take 100 seconds just about. Well, I guess it would take a little bit longer for every device to pull. But for light speed, it pulls groups of devices at the same time, so it's very rapid. And that would allow the device to activate quicker, because it's only checking the device when it pulls. So if I pulled the pull station when it just finished the 100 device loop, that means it's not going to turn on the alarms for 100 seconds. So obviously that's not too good. If you hit verify loops, it's just going to check everything. And as you can see, system is okay. You would obviously know if something's wrong based off if the panel said trouble or system unnormal. Thank you for watching. I hope I didn't miss anything in this video. Obviously, like I said, it's not a training video. This is just for people to learn more, or maybe it would help if somebody's having some trouble with their demonstration alarm system or something like that. So thank you guys for watching, and I'll see you guys in the next video. Thanks. Peace out.